Good morning, everyone. First of all, I apologize for not being able to join you today in Zagreb. I hope you are really enjoying the NEM Initiative Conference. My name is Marta Brescia and I am a PhD researcher at the Universitat Autònoma de Barcelona. I am also part of Transmedia Catalonia Research Group, and today I'll be talking the next 15 minutes about subtitles in 360 video, results from an eye tracking experiment. I'd like to say that this is actually a follow-up presentation. Chris Hughes already presented all the technical issues related to testing in immersive environments, and now I will present a more practical approach. In this presentation, first we will go through the challenges when creating subtitles in immersive VR 360 environments. Then I will show you the details, experimental design, data collection and data analysis in a user test with involving subtitles in VR 360 environments. And I will conclude with some ideas and further steps from this research. Starting with the challenges when creating subtitles in immersive environments, it is important to remember that now there are many solutions, recommendations, and even standards specification for subtitling traditional 2D content. As you know, in traditional 2D, the audiovisual content is framed onto a flat 2D window. However, when it comes to VR 360 videos, users have a freedom to explore around a projected 360 sphere. This fact raises many challenges and opens also questions for which appropriate solutions are required. Additionally to all the challenges presented in 2D, which are the presentation mode, the representation of the non-speech information, text font size and background, and also reading speed and character per second and per frame, we have to add new challenges when we deal with immersive content that are the position of the subtitles and the rendering areas in the 360 sphere, minimizing blocking effects to avoid a negative impact on comprehension and immersion, maximizing readability and minimizing VR dizziness and VR sick, the guiding methods to guide the users around this 360 sphere, and also the character identification. That said, trying to give some answers to all these new challenges and trying to understand which is the best way to visualize subtitles in 360 environments, we decided to carry out several tests with final users implementing subtitles in 360 environments. I say we because this is not only me. I'm working together with Chris Hughes, with Andrew Duchowski, Chris Krecht, and also Pilar Orero in these experiments. Now I will go through the experimental design, the data collection, and in the data analysis, I will offer you some results from our experiment. Regarding the experimental design, we follow a 5-step methodology. First of all, we define which kind of material we wanted to test with, and then we obtain or create this material, basically 2 different 360 videos. Step 2 was to design the questionnaire. We were using Qualtrics for that. Step 3 was to elaborate the subtitles. We designed 2 visualization modes. I will go deeper into that in the following slides. Step 4 was to implement the subtitles in the videos using a web-based editor and player created by Chris Hughes. And the final step, step 5, was to test the experiment set up using Unity. I know that Chris Hughes already presented a web-based video player that he developed, and now I want to show you the web-based subtitle editor, which was also developed by Chris Hughes. And this tool has been essential for our experiment as it allows to create subtitles in 360 videos. Here you can see a screenshot from this tool, and it is basically an editor that looks like a regular 2D subtitle editor, but it includes the possibility to locate the subtitle in the 360 sphere. So you can decide where the subtitle is going to appear in the 360 sphere. Okay, regarding the design, as I said, we recorded 2 clips to 360 videos. One is called Vacations and the other one is called Traction. We were testing 2 different conditions, position and color. For position, we had 2 different options. We had headlock. That means that every time you move your head, the subtitle goes with you. And we have fixed. Fixed means subtitles appear close to the speaking character and they don't move. If you move the head, the subtitle remains in the same place where it appeared at the first time. Then the other condition was color, and then here in color we have again two possibilities. We have black and white for all speaker. That means white font in a gray background. And then the second option was a different color for each character, so it can be useful to identify the speaking character in each moment. This figure shows the data collection method we followed during our experiment. First of all, and after asking for the ethics certification, we asked the participant to sign the consent form, and then immediately they started with the first questionnaire, which was about demographic issues. Then we prepare all the VR headset setting and we calibrate the eye tracker. We explain the participant the main instruction, how the experiment is going. Then they watched the first clip, the first video, and after the video there were a few questions with some NASA TLX and comprehension questions. Then second clip, again a questionnaire with quite similar questions, including NASA TLX and comprehension. And after that we had one last questionnaire with asking for some comparison between the 2 clips preferences. Now for the data analysis, and just to show you some results from our experiment, here we have a figure corresponding to the first study we carried out in Barcelona, the UK, and Poland. We had 73 hearing participants, and they identified fixed subtitles as easier to read. And when we went through the eye tracking data, we did the gaze-based analysis of subtitle reading, total fixation count on subtitles areas of interest, and it reveals that there was a main effect on subtitle position and showing more fixation in headlock, meaning that, or that can be interpreted as headlock being the best visualization mode for subtitles in 360 environments. As for the second study we carried out, we had 39 participants between Barcelona and Ljubljana. They were all of them were hard of hearing or deaf participants, and the effects of subtitle position was statistically non-significant, so I'm just showing you the results for subtitle color. Again, we carried out the gaze-based analysis using the eye tracking data, and it reveals that effect of subtitle color was statistically significant for deaf and hard of hearing participants. So fixation count on color subtitles is greater than on monochrome subtitles, meaning that having a different color for each speaking character helps identifying this character in the 360 sphere. Regarding conclusions and further steps, some conclusions after this experiment were that it is important when you test new technologies with end users to show them a working prototype, because if you only ask, it's going to be hard for them to understand what you are meaning with this new product, and it's going to be hard to give a proper answer. So paper prototypes might cause confusion in that sense. And often they lead the participants and the users to say that they prefer what they already know or what they already have. In this area specifically, there are many new technologies. It poses also a learning challenge, and it is difficult to ask a user to evaluate prototype when they are still learning how to use this new technology. That means that the expertise of the users is very relevant when testing these immersive technologies. And finally, I'd like to say that all previous studies involving accessibility in 360 environments relied only in subjective methods such as questionnaires and focus group. And we realized that there is a need to combine these questionnaires and a focus group with new techniques like eye tracking, which are objective measures, so we can obtain more scientifically significant results from these studies. Moving to a more general background, a more general frame, we can conclude that the only way to ensure a truly accessible immersive media experience is through 4 key XR accessibilities, which are the media content, the media player, the user interface, and the device. Basically, to sum up, extended reality to be accessible, both the content, the media content, and also the container must be accessible. Actually, if you devoted a lot of efforts in having a very accessible content, but the platform you are using to consume or to watch this content is not accessible, then nothing works. It also includes, of course, translation. So within all this layer, we also have to consider the multilingual aspect. To finish, I'd like to give you some new ideas, some new avenues for extended reality accessibility. And I want to present you this web-based app, which is called Greenverse. We are developing this app as part of the GreenSend project, and it allows to create immersive stories, including accessibility services such as subtitling and audio description. The platform is still in the beta version. Here you can see a screenshot from the platform, and we are now testing the platform. For that, we carried out a first workshop with students at the UAB last summer. The students gave us valuable feedback, and the results from this first exploratory study are now published in a book which is called Bridging the XR Technology to Practice Gap. So if you want to know more about this project or the results from the experiment, here you are the reference, so you can look for it. It's open access and available online. And that's it. Thank you for your attention. And if you have any question, I know Kshish would be very happy to answer. And you also have here my email address. And I will be also very happy to try to answer your question. Thank you.